our goal today is to give you briefly introduction of what data science is and how you can apply it to a research in your field, behavioral science research. So I would like this talk to be not a lecture, but a discussion. So please feel free to stop me anytime if you have any question, or if you want me to repeat any particular topic in Thai. I can explain that short, more detail. So please feel free to stop me anytime. Okay. First, let me introduce you about myself. My name is Werayuth Charoenruengkit, or in short, V. I currently working as assistant professor at the Department of Computer Science, Faculty of Science at Srinakharinwirot University. I teach software engineering, programming, data science, data visualization, and other topic in that area. I also work as a deputy director of the Central Library on the IT department, where I look at all the IT in library, including website, application, and data management. So if you need any help or anything from library, I can help you contact to our librarians. I was invited to teach courses in many places, courses like data science, software engineering, digital marketing, at, for example, Bangkok, I don't know real name, Keynote Institution, Thonburi, Stanford International University, at Charoenruengkit. I went to my education. I went to Keynote Institution of Technology, Lakabang, and went for graduate school in master degree in University of Florida and a PhD at Florida Atlantic University. I also have industry work experience. I worked for IBM in US for several years, and teach as adjunct faculty members at City University in Seattle for about 2 years before I returned back to Thailand. Okay, this is about me. The topic that we talk today will be as follows. First, I will introduce you to what data science is and the process of data science. Then I will give you example of data type that can be used in data science project. Then we look at the machine learning algorithms to process all this data. Then we look at some of the application that you might be able to relate it to the topic in your research in your field. And then I will give you a couple of tools that you might be able to use. Some of them is very basic. So without any data science background, you can download and then play with it. Some of them need some more advanced knowledge, and that might be a good for collaboration if you want to do research with the computer science department. Then I'll show you a demo, a quick demo that so that you can see what data science can do. Then at the end, we do a question and answer. Okay. Just a moment. Okay. So first, let me tell you what data science is. Data science is a combination of multiple disciplines, including statistics, scientific methods, artificial intelligence, or most people call it AI, data analytics. And the purpose of data science is to extract some value from data. If you have a lot of data, you want to extract some information that you can use for business or to solve research problem. So we want to extract those value. Data science, as I said, data science is a combination of different disciplines. People who work in data science should have some knowledge on data engineering, scientific method, mathematics, statistics, some computing knowledge, and then you also need to understand how to visual data, which is called data visualization. And the most important is you need to understand what's the meaning of the data. That means you have to have a domain knowledge, meaning that if you're doing research in behavioral science, for example, you need to understand the data that you collect, what that means, and then you can use all this knowledge to process all those data based on what you know about data. Okay, so the data scientists people sometimes they understand all the techniques and method to process data, but they don't understand what the meaning of those data. And what I try to say is, in order to make data science projects successfully, we need some collaboration between people from different fields. Okay. And you might be hearing different terms that related to data science. For example, you might have heard data mining, data analytics, data analysis, or even big data. All these terms essentially meaning the same thing. There's some few different meaning in those terms, but people always use it interchangeably. So sometimes people call data science as data mining. Sometimes people call data science as data analytics. But essentially, data mining is just a part of data analytics, and it's part of the whole data science. Okay, there's different level of data science and data analytics. I'll show you later in the next slide. The data mining, the meaning of data mining is meaning that it uses data analytics and data analysis to process data, which is the subset field in data science. Okay, and the machine learning. The machine learning is an algorithms or a techniques that that computer can use to process all this data. Okay, it's a computer algorithms which use the knowledge in statistics and probability. Okay, you might hear deep learning. Deep learning is just a subset of machine learning. It uses some advanced and more complicated algorithms to process data. Okay, and AI is just a superset of everything. Nowadays people call data science, machine learning as AI. Okay, but there's some subset field in the AI discipline. Okay. And now, what is big data? Big data is just a last chunk of data that we can use machine learning or data science process to extract knowledge or value from this data. In general, big data is a size of like 1 terabyte, which includes text, picture, audio, or can be just a business data or survey data. But this data has to be very large, in the size of maybe 1 million rows of data. Therefore, it needs some very big, a powerful machine to process all this data. In the Department of Computer Science that I work for, we have a two machine that can able to process this data. Okay. Now let me explain to you the different type of data analytics, which is essentially a data science. Okay. If you look at the y-axis, this is the value. Could be a value to business or value to research. Okay, the higher this process is, the higher value it is to the business and research. And on the x-axis, show how difficult it is for analyze the data. Then I'll show you different model. Okay. The first one we call descriptive analytics. This is to answer research questions such as what happened, based on the knowledge, based on the data that you collect. For example, if you observe some data and you collect it put into the Excel spreadsheet, or a survey data that you will collect from maybe 100 or 1,000 people, then you want to know what this data tell you. Okay. And this process is called descriptive analytics, where it will answer a research question as what happened. And answer to that could be something like, if we look into business data, we could find something like we have a lowest revenue in Lampang province, where the revenue would be maybe 2 million baht. And however, the highest revenue that we get would be from Bangkok, which is 50 million baht. This often used in the business report, where we find the average of something, right? And this average number or a median of this number will tell us something about data, right? So there's some business value to this answer, okay? But if we want to get more knowledge or get more value from this data, we'll ask more questions. To this question, we ask what happened, right? We could ask again, why did that happen? So we want to know why we have a lowest revenue in Lampang, or we have the highest revenue in Bangkok. Why? This is called a diagnostic analytics. Okay. In terms of research, we do this all the time with the causal analysis, or we do a confident interval to see how some factor would be effect to another factor, right? So we want to know the relationship between all these variables. So this process is called diagnostic analytics. So in this example, we already have a descriptive analytic result. Now we ask again, why did that happen? So we use another process to look into the data again, and we could find something like, oh, the lowest revenue is in Lampang because it happened only in July, and that because of there's some network outages. So there's some network problem. That's why we have a lowest revenue in Lampang, and that just only happened in July. So this creates more value to the research question or the business question, right? It's go higher to the y-axis. Now, if we want to gain more value, how do we do it? We use the analytics methods called predictive analytics. The predictive analytics is to answer the questions like what will happen? What will happen in the future? This is what data science always used to answer this question. Okay? Data science discipline will collect data and predict what will happen in the future. Or if we have something, some new data, we'll predict what it is, what data represent. That's what data science do. Okay, so in this case, the predictive analytics will answer what will happen. And after we do some research, we might find the revenue in Lampang next year will be something like maybe 5 million if we fix this network problem. Okay, if we fix the network problem, revenue will be higher, and will be higher by how much? The predictive analytics will answer that. Okay. Now, if we want to go higher to the analytics escalator, we will gain more knowledge from data, and again, it will be more difficult. Okay, it needs a more complex process to process this data. Okay, the next question that will be difficult, more difficult, is prescriptive analytics. This will answer some a question like how can we make it happen? Meaning that if we want the higher revenue in Bangkok or in Lampang, what should we do? What should we do? This requires complicated AI algorithms or optimization to answer this question. So the algorithm and the process will take data and process in different dimensions, and will answer something like, oh, we should sell a plan B, we should sell a product B, product A in Lampang, so that our revenue will be maybe $100 million, 100 million baht. Okay, so this process we try to optimize the decision that we make. Okay, but again, it's more difficult, and it gains more value to the business and research. Okay, any question on this? Okay.
No question, but very interesting, Aja. Thank you.
Okay, okay. Now you might have a question: what the difference between data science and computer science? Okay, computer science is a study of computational system and theory, and the knowledge included in this area are artificial intelligence, database, human-computer interaction, computer vision, and other computational tasks that involve data processing. This is what data science do. Oh, no, sorry, computer science do. But data science utilize all this computer science knowledge to automate data processing by using all the statistical analysis process. So data science basically use the computer science knowledge to automate things, okay, to process everything in an automation manner, so that we can extract the value from data. And those techniques called data prediction, classification, and clustering. So there's some overlap knowledge in computer science and data science. That's why you see many computer science people work on data science project. Okay. And I believe everyone in Behavioral Science Institute have worked with statistics for their research, for your research. So I will highlight some differences between data science and statistics. Okay, from based on what I know, the statistics will summarize data or do some data inference based on building a general model, a generalized model that fit to the data sample that you collected. And based on the statistical theory, you can like quantify the result by using some statistical significance or some significant interval using a measurement like R-square or p-value. Then if the research found that R-square value very high or p-value very low, then you confidence that, based on this number, we can confidence that our assumption is true. Okay, and that kind of in the level of diagnostic analytics, you try to prove something. We try to prove something based on the statistical theory. The data science look in a more application level. Data science do the same thing. Try to do data inference and building a generalized model, doing the same thing as the statistic research. But instead of trying to use R-square and p-square to quantify the result, data science try to separate data that collected into two sets. One set is called training sample, and the other set called testing sample. And the model is built on the training sample. And this generalized model is trying to fit a statistical model to this training data and avoid overfit data. The meaning of overfit data is try to not try to tune the model closely to the training data too much, because the data science will evaluate this model based on the other set of data. So we build model, data science build model on training data and evaluate the model on the different set of data. And the result of the model will not quantify based on the R-square or p-value, but based on the testing result, which could be if we do linear regression, the result would be comparison of root mean square error on the testing data. If we do a classification, we will quantify based on the accuracy. Like we do face recognition, the quantify of the result would be the accuracy, how good it is to recognize people. And again, we could quantify the result based on the type 1 error, false positive and false negative of the testing data. Okay. Now let's look at the data science as a process. Data science sometimes look at a discipline of study, but it can be viewed as a process of doing data science project. Okay, for data science, it always start with data. We have to have some data. Okay, and this data will be processed through the process called data preparation, which include data manipulation, data blending. Data blending meaning that we have data from different sources and we try to combine them and try to fix the problem with missing value, meaning that some value is not collected. This data preparation will try to manage how to make this data complete before the next step to process the data. Sometimes this process called data engineering. Okay, so the data engineering is part of data science project. And once we have the data ready, this data can be used to create a model. As I said previously in the previous slides, we try to fit a model using statistical theory or a statistical model to fit this data. And this model will be created by the process called training. Okay, so our teaching, we teach the model or we train the model. And once we train the model, we try to optimize them. This optimize meaning that we try to tune the parameters of the model or using some regularization or do many iteration. Once we train the model and optimize model, we can do model evaluation, meaning that we do a testing model on the separate set of data, which is called testing data. If this process done well, we can assume that the model is generalized enough to be used for the real-life application. Okay, and this training process sometimes use the machine learning or we call a training algorithms to create a model. Okay, if you're familiar with linear regression, you get data from survey and then create a linear regression model. Okay, but in data science, usually we focus on the evaluation of the model on the testing data. Okay, and once we have a good model, the model can be used to create a report or application. As you can see, the face recognition application, the AI application, like if you want to open, you look at the Netflix, for example. Netflix recommend movie that you might be interested in. Okay, that based on the data science process behind the recommendation, what movie that you would like to watch. Okay, so that comes from the training of the model, recommendation model. And once it trained and prove that the model is good, then they use on the actual website that try to recommend a movie that you like. Okay, but if sometimes the model is not correct, okay, sometimes the model is not correct, the process go back to the different process, including to try to evaluate the model again with separate set of data, or try to retrain the model again, or even to collect more data. This can happen. Okay, so the data science project always the iterative process. If any step is not work, does not work, it's go back to the previous step. Okay. Now, what kind of data that data science can process? Okay. There are two main categories of data. The first one called structured data. Usually the data in kind of a table from database or survey data or business data, data from ERP, from CIM, or from the sales record that business collect. Okay, or a Likert scale survey that we often see a research project done, or any numerical or text data that can be organized in the row and column. This is called structured data. For example, this data show the user ID 42 watched this movie, River Why, and give a rating of 3. Okay, so this data organized in row and column. This column show a rating, which is number. This column show ID. This column show a title. So any data that can organize in this form we call structured data. Okay. Different type of data called unstructured data, which is the data that cannot be organized in this table. The example would be audio data. The audio that being recorded while I'm speaking, it cannot organize in easy form of a table. Image data, face picture, that's unstructured, or text data from maybe some social network, from a messaging application. This is not a data table because we don't know which one is verb, which one is subject, which one is object, or the meaning of this text. Okay, so this is called unstructured data. So the data science will process, we try to extract the information from data from different sources. It can be a structured data such as data from CRM, could be unstructured data from Twitter, from Facebook, or even from a measurement like heart rate. We can put a sensor on our chest and measure the heart signal, or brain signal. Okay, and those data will be combined and cleansing and transform into a data that we can process easily. And usually this data store will be a database in a structured format. So we have, could be unstructured or structured data. We pass it to a process called ETL, which is extract, transform, and load data. Okay, load means loading into a database. Once it loaded into a database, the data becomes structured. When data becomes structured, we can process easily using any data science algorithm or machine learning algorithms. Okay. I'll show you example. If we have an image, okay, it could be a picture of someone. Once we have an image, there's some function, it's called maybe fx, some function of x, and x would be this image. The image will transform into some kind of number, a vector of number. And there's different function. They're not a single function. One function would transform this image into this set of number. A different function would transform it to different set of number. Okay, and one research topic in data science is to come up with this function x that can extract the more meaningful knowledge from the picture. Okay. Next. Audio data. Audio data is also unstructured data. This might be someone singing a song or someone speaking something. Okay. We can view this in a frequency view. This is called spectrogram. This is to investigate how how much energy in each frequency of this audio. One audio contains different frequency of sound. So this show different frequency energy. Okay, and data science project or data engineering step in data science process, we try to extract all this information or information from the audio. Okay, use some kind of windowing or measurement of the amplitude of this audio, and finally, what we hope to get is some kind of a table of data. For example, maybe this is a song. Suppose this represents a song. This song would give us this is danceability, meaning this song can be danced with, or what energy level of this song, or it contains audio speech, human speech, or any instrument in here. So once we have this kind of table, then data science algorithm can process this. Okay, in data science, we can process data only if they are number. Okay, if the data are not number, then we transform them into a number before we process it. Okay, now let's look at the image. Let's say we have a face of a person. Then we try to extract some number from this picture. There are different function of x that transform this picture into a number. Example would be create a small square of different part of the picture and look at the histogram of the intensity of the color. Once we have the histogram of each small square, we concatenate them. Once we concatenate them, it's become a vector of number. So basically what we try to do is try to create a function of x. In this case, x is a face of person. Then it becomes a long vector, which can be a histogram or can be something else. Okay. And this, again, another example, a text data. Try to transform this word into a vector, into a number. Let's say we transform cat into this vector, 0.6, 0.9, 0.1, where each number represents something. In this case, the first number represents living being. If it represents living being, then this number should be very high. Like in this case, 0.6. Feline, yeah, then 0.9 because cat is feline. Human, no, it's not human, but it has some human feature, so it is 0.1. Royalty, no, it's not, definitely not royalty, so it's minus 0.07. And then something else, for example, houses is not living being, so it's 0.08. Negative 0.8. Has gender, maybe house might have a little bit of gender, so 0.1. Is it plural? Yeah, yes, it's plural, so it's 0.8. So we try to transform word into some number that can represent those words. Similar to the picture, we try to transform the picture into number that can represent a face of person, maybe big nose, a big mouth, a small eyes, thing like that. So this vector will represent those features. If we can transform unstructured data into number with structure, it could tell us something about the data. In this case, for example, if we plot this cat and kitten on the two-dimensional graph, we will see that cat and kitten are very close to each other. Okay, that means cat and kitten meaning something very similar, whereby house and dog are totally different things. Okay, because the vector tell us it's very far away from each other. Okay, and similarly, a man could transform into this kind of vector, woman this vector. Okay, and like king would be on this side, man would be on this side, and woman would be on this side. Okay. Any question on this? Okay. Now, once we have data in form of number, usually a vector, okay, this again, this number we usually call vector feature. Okay, a vector feature. Vector feature represent the actual data. Okay. Now look at the machine learning and data science that used in data science project. Machine learning is a set of rules and statistical techniques that used to learn patterns from data and draw some significant information or a value from the data. Machine learning will help us answer questions like how much or how many, which called regression. We answer which category from data. We want to know which category this data belong to. This called classification. Or which group. If we have data, it try to group the data into different groups. We answer, is it weird? Meaning that we try to detect anomaly of the data. Okay. Could answer something, try to recommend things. Like example, I show you previously, try to recommend books, recommend movie to the user. I'll try to do association. Okay, I'll show you example on this later. Okay. Now let's, the machine learning has mainly has two classes. The first one is called supervised learning. The supervised learning try to train a model based on the label that we have. Usually we hear something like, oh, we try to teach computer by giving them data and tell them what it is. For example, we give picture of cat, okay, to machine learning algorithm and tell them, oh, this is cat. And we have picture of dog and give to machine learning and tell them this is dog. Okay, the what we tell them is the label of data. So this called supervised learning. We have data and we have label. Okay, the class of this supervised learning, example of this class is regression and classification. I'll show you more detail later. Another class of machine learning is called unsupervised learning. The unsupervised learning will try to extract information from data without any label. So we don't tell the machine learning model what this data about. We just dump data into the model and ask the model to do something for us. Okay. Example of this class is clustering algorithms, association, or anomaly. Okay, I'll show you more detail later on this. Okay, the first one, very simple one, and I think everyone here already familiar with it. It's called regression. Okay, regressions try to model the relationship between some variable to another variable. I believe in the social science research, we call this is independent variable. Right? We have a different independent variable, and we try to see which independent variable is the influence highly to the dependent variable, right? So we collect
Yes.
data, we collect a lot of data and try to see which factor highly influence to this value. Okay, but in data science, do something very similar, but instead try to see which factor is highly influent to this dependent variable. What data science to do is try to predict exactly what's this value going to be. For example, we collect the information about houses. This houses has a two-story building, has a three-bedroom, has two air conditioning. Those is the independent variable that we collected. And then we know the house price. If we have this information, we know the price of this house should be 2 million baht, 3 million baht. And we go to the next house and collect data, and we know the price of the house. And we use that number and try to create this equation. Okay. And again, we can answer the same thing. Which feature of the house highly influence the price of the house? But the data science project or data science research, we try to predict the house of the price of the house exactly what it should be. Let's say a real estate agent have information about house. It has two-story building, one bedroom, and he or she want to know at which price he or she should put on the market so that it can be sold very quickly. Okay, so if we can come up with this equation that will help real estate agent or owner of the house decide what price the house should be sold for. Okay, there's some variation of, as you know, there's some variation of the regression model, which is the nonlinear modeling, or maybe polynomial modeling. And sometimes we don't want the model to be more complicated. We like model very simple. So the regularization often used to avoid overfitting on the data. Overfitting on the data meaning that we create a model that fitting too much on the data that we have, but we don't know what it's gonna be if it perform on the data that we don't have for the future that we try to predict. So we want to create a model that very generalized can be used for actual data in the world. Okay, this is called regression model. The next algorithm that used in data science discipline would be a classification problem. These classification algorithms will try to separate or predict data into different classes. Okay, by which we tell the machine learning, we create a model, and we tell the model this data belong to this group, or we tell them the label of the data. And then once we have a good model, for example, in this picture, we tell them this star belong to a class A, and this triangle belong to class B. And then if we give the model, we input a new data to the model, and we ask the model to decide which class of this data set of this data sample belong to. Okay, the model could decide that, oh, this could belong to a star or could belong to a triangle based on the result from the computation of the model. Okay. The application would be something like this. We have customer, which we come into the store and we record if this person buy product from us or not buy product from us. The first person, less than 21 years old, very high income, and male gender, and not married, single. This person not buying anything from us. Okay. This person 21 to 35 year old, very high income, gender male, and not married, single. And this person buy product from us. Based on this number, let's say we have another person coming to store. Okay, we create a model from this data, and this new person come into the store, and we don't know if this person gonna buy product from us. We don't know. Then we try to predict if this person gonna buy product from us based on the previous collect data that we do. So we create a model from this data and try to predict what's this person gonna buy product from us. Okay. Example of this algorithm is decision tree. This model is created on the past data that being collected. For example, this person has income less than 25,000, family member less than 4, education level less than 12 years. This person always purchase product from us. Not always, but most people in this category buy product from us. Okay. Now, if we have new person come in, we can go through this tree and to see if person gonna buy product from us. Let's say if person fall into this purchaser category, we would go talk to them and service them specially. Okay. Next algorithm is anomaly detection, where we have a data of normal operation of any data that we collected. For example, we might measure some IQ person. Most people IQ will fall into this eclipse. And then if new person come in and we do measurement and the IQ fall outside or far away from normal people, then we will say, oh, this person has something different to most population. Then, but something we don't know what they are, but we know there's something. So we would do more study on this sample or this subject. Or it can be used in maybe medical signal. Let's say we measure the heart rate of people, and the heart rate always fall into this pattern. And if the sensor detect that, oh, there's some spike happen, then we know, oh, there's something happened to this person. Maybe we have to do more diagnostic on the health of the person. Okay, this is called anomaly detection. It can be used in the factory where we put sensor on different machine, and then if machine show us some different signal from previous pattern, then we know, oh, the machine has problem. Then we try to have people fix it. Okay. For the unstructured, unsupervised learning, we don't have a label of data. For example, we have this set of data set, and we want to group them. We want to see, let's say this is a customer, and we want to segment customer into different group. Okay. Or we have sample that we collect from a survey. We don't know how do we group these people into different group. We can use data mining, machine learning to cluster them. The machine learning can cluster this data into maybe 6 groups. Okay, if it is grouped into 6 groups, it will create what we call a centroid at the center of the group. Okay, and then the owner of the data can look into this group to see why machine learning put them into the same group. It uses some commonality of the data to group them. But it's sometimes we ask them to group it differently. For example, if we ask them to group it into 3 groups, the machine learning can put this group together in one group, or maybe this in one group, or maybe this in another group. It could happen. It can detect, oh, this is maybe outlier, or this may be outlier. Okay, so machine learning can try to group data and see if we have any outlier of the data as well. Okay. Another machine learning algorithm that often used in the retail is called association rules. Let me give you an example. The association rule try to extract the pattern in data set. For example, Lotus, 7-Eleven, or Big C could try to analyze the purchase of each customer to see what purchase or what product that they buy for each time that they visit the store. Let's say the first person buy apple, beer, rice, and meat. The next person buy apple and beer. Next person buy bottle, maybe milk, beer, and rice. Then of maybe 100,000 customer, they might be finding some pattern of product that people purchase together. For example, in Walmart in US or Target, I don't remember, they analyze all the purchase pattern of people, and they found most people buying milk, buying Pampers, children Pampers, and beer together. And at the first time, they kind of wonder why that happened, because beer is often for adult and Pampers for a baby. And then later they look deeply into data, they found that, because people who buy Pampers and beer often a male and a husband, in which wife asked him to buy Pampers, and instead of just buying Pampers, he buy beer to drink at home. So this superstore find pattern of purchase, so they decide to put all this product together or create a package of discount so that they can increase the sale of these two products. Okay. This is the one that I mentioned earlier, the recommendation system. Recommendation system try to predict the preference of a user. For example, in this picture, you see this person read this book, and she give a rating on each one of them. For example, she give a rating of this book at 4, a rating of this book at 3, a rating of this book is 5, and the next person, this person give rating of 5, this book of 4, but he didn't read this book. He didn't read this book. And what we're trying to do is try to use machine learning to predict or to recommend a book to this person. Okay, so to recommend the book to a book to this person, we want to know what she gonna rate if she read this book. What she gonna rate, give a rating if she read this book. Let's say we try to predict number, and if we predict that this number is 4, meaning that she might like it. So the recommendation would put this on a website or on her account that, please read this book. But if the number over here is 1, then the website would not put this book on her screen. Okay, if the prediction is correct and the system recommend correct book to the person, then it's likely that the person would buy more books. Okay, and this is what machine learning algorithm do for recommendation. Another class of machine learning is time series analysis. Time series analysis is try to predict what's going to happen in the future, okay, or the next sample in the future. For example, if we collect data of a COVID-19 infected based on the number of tourists, based on the number of store open that we have currently, then we plot them and put them in the sequence. We know how many people infected by COVID-19 at this time. And then if the policy of the government change, by which we allow more tourists to come into the country, then we can predict the number of COVID-19 infected for next month or for next year. Okay, so this is time series analysis. Or we can predict the PM, the weather condition maybe. Okay, the weather condition for tomorrow or for after tomorrow, based on the weather condition in the past and based on the different factors. Okay. Okay. Now,
Ajahn, I have a question.
Yes.
It's very interesting, and I would like to know whether, like, can you predict whether what will data science will be in 10 or 20 years from now? Will data science replace traditional statistical research or not?
No, definitely
no?
not.
Okay.
Because the data science use statistic theory, and if there more, if there new theory or more techniques or method in statistics, then data science will adopt it and use them. Okay, it's always
so it's not. Yeah, that's great. So yeah, I still have a job, I guess.
Okay. Yes.
Yeah, thank you.
Okay, I'll show you a couple of applications if you're interested in working, adopt data science into your research. Okay, a very simple data science is data visualization. Okay, for example, if you have this number, at first you try to extract some knowledge from this number, and it's very difficult. Okay, let's say I ask you, which category of occupation and region would be the best customer? It's hard. It's difficult to extract the knowledge from here. But if we look at this data again in a graph, then we'll see immediately the best customer would be in the professional field and in North America. Okay. So from the simple data in spreadsheet, we can create a data visualization that can give us more value to the data. Okay. Another example is the keyword analysis, which what I'm doing, trying to do at the moment. What I try to do, and me and my team, is try to extract the keyword from research paper published by faculty member from Srinakharinwirot University. This is some example that I extract keyword from paper published in Scopus. Of all this paper, the keyword human and female control study happen very often in those papers. Okay, meaning that research that happened in from Srinakharinwirot University always focus on subject of human. Okay, but this is just a pilot project. I try to collect more data and clean up data some more. For example, there's some mistake here, humans and human. It should be just one word. Okay, and once this done, I will put this on a library website so that people can see that the direction of research in the Cebu community. Okay. Data science can be used to analyze text, okay, or sentence. For example, if you read this sentence, say, "I'm very happy with water bottom." This show a positive sentiment, right? So meaning that I like this water bottle very much. But if the person says this is bad investment, that means it feels negative. The person feels negative. But instead of have human read this sentence and try to decide if the person feel positive or negative, we use data science theory to process all this data and try to predict the feeling of this person. Okay, there's some project, a company that try to pull data from Twitter or from Punchip and try to predict what people feeling on a bank institution or from a government sector, okay, based on what people wrote on social networks. Okay, this application called sentiment analysis, and it can be done on Thai language as well. The next one is chatbot. You might be using chatbot at some point. Let's say you ask what left on my card. The data science algorithms behind this chatbot, you try to interpret what you meant or what your intention. Then it try to respond based on what your intention is. In this case, it go to data and database with information about you, and then get information and answer back to you. Okay, so the first challenge is to predict your intention. Okay, based on this text, what you want, what you want to do, what kind of response you expected. Okay. Or the data science can be applied to process video or picture. For example, we teach machine learning model the behavior of this person or different people. We say, oh, this is people standing, this is people fighting, and then we put camera on a public place, and once the camera detect if there's someone fighting, and the machine learning model behind the in the computer behind the camera process all this picture and this decide, oh, this is people might be fighting, then it give alert, then we know, oh, this might be people fighting. And it's not always 100% correct, but it gives some quick response to some incident. Okay. Data science can be applied to guess emotion of people, by which we give different sample of picture. Like this, we tell machine learning model that these people feel disgust, these people feel surprised. With maybe 1,000 sample, then computer use the statistical model to understand, oh, if the picture something like this, it will be discussed, something like this will be fear. Then if we have a new person come in with no label like this, we have no label. Okay, if this person, oh, sorry, this person with no label, then the data science model, machine learning model will try to guess what this person is feeling. Okay. Or it can be used for social network analysis, where we can pull the data from maybe from Facebook and see if this person know other person, and if we can create a network of people know each other, or maybe a research group. One person do research with another people, this person do research with another people. We can create a network, and then we can try to group them or try to make recommendation of maybe a book. If I work in a library, I know if you like this book, I could recommend this book to a next person in your networks. Okay, and this is what Facebook do. If you're a friend with someone and there's someone buying something, then Facebook try to recommend that product to you as well. Okay. This is some research work that done by our faculty member, the faculty member at the computer science department. Dr. Chantri has some work in brain signal detection, where he used the brain signal to predict what people are thinking and try to write email based on what people are thinking. Okay, this is his work done on, he used some complicated algorithm and very expensive machine. Okay, Dr. Nui create a mobile phone, assist student in learning, and maybe try to learn pattern what student learning, and compare the performance of how people learn, how students learn from mobile phone or how people learn from the actual class. Then try to make comparison. Okay, there's some other research in this data science. Let me show you this better. Okay, let's show you this. Sorry. Okay. Example of other data science project that have been done in the computer science department. You can access those projects from IR.SWU. This is institution repository, which store all the research paper or some project that not published outside university in here, so that people in the SWU community can access and maybe can continue the research work. This project done by student, undergraduate student before they graduate. For example, this is a smart garage. There's some project that done with the student to detect which news from Twitter is a fake news or which news not a fake news, using data science algorithm to process all this text. Or other faculty do a smart house using data science algorithm to detect something happen in the house. There's some different project that you can look in here. Okay, and that different faculty member. If you want to maybe work with our faculty member, we have 12 faculty members in the computer science department. You can email them directly if you're interested in. You can contact me, no problem. Okay, while I'm here, I want to show you what this website about. This is called institutional repository. where different faculty can upload their research paper that not published outside university, but want to share this knowledge to people in the community. For example, we have faculty of engineering placed like 1,900 publication on here. Fine art 183, humanity 329. So if you're a faculty member, you can contact library to put your document on here, material on here, or even teaching material on here. If you are a researcher, you can to see which research paper that you might be interested in that published by the civil community. You can search from here. Okay. For the tools, if you want to get into data science study and you want to start doing data cleansing, meaning that you have a lot of data from survey and you want to clean data, there are different tools that easy to use, like OpenDefine. OpenDefine is open source that you can clean a large set of data, like you have a data with maybe 100,000 rows and you want to clean them. This tool can process them. Or Pentaho, a little bit more difficult to use, but very powerful. Okay, so these two are open source that you can use. But if you want to do data visualization, you can use a software like Tableau, Power BI, or Data Studio. All these tools are free for education. Okay, Tableau, if you have a G.Su account, you can get a free license of Tableau. If you don't, you can use it for free for 15 days. Power BI and Data Studio is free. You don't need any license. If you want to go higher into the analytic escalator, you want to do a data science project using machine learning, you can use software like RapidMiner, Orange, NAM, or Vega. The one that I recommend would be NAM or RapidMiner. Today I'll show you what RapidMiner is and show you a short demo. Okay, but I would recommend using NAM better because this RapidMiner is commercial. And you might need to pay if you have a large data set. Okay, but NAM is open source. But if you gain more knowledge and you want to do advanced things with data science, you can write program using Python or R. Okay, but most people in the data science community always use Python. Okay, and we teach that in the computer science department. If you're interested in, you can contact our department. We do training all the time. If you're interested in, we can arrange training. If you have a large set of data, you can use service, but all this not free. You can use Google BigQuery, which can store you a large chunk, a terabyte of data, 10 terabyte, 100 terabyte of data, Google BigQuery, and can return results very quickly. Or you can use AWS, Amazon. All these are cloud service that usually used to store big data. Okay. Okay. Now let me show you a demo. This software called, just a moment. This software called a RapidMiner. Okay. I'll show you quickly what it does. This is the medical fraud detection. It's a sort of drag and drop tools. So let's say you have a data. Hang on, just 1 second. Let me run it and show you. So each box will process data and do some machine learning model. So you don't have to write any code. You just drag and drop the process from here. For example, if I want to create a model, a predictive model, I can drag it to the canvas. You connect all this process into a different box, and then it will run some computation. For example, this data set, it has some independent variable called a number of prescription, amount paid by patient, and a number of prescription, different variable. And then what I try to do is try to predict whether this is the insurance fraud on try to claim the fault insurance claim. Okay, so this is the actual result. This is not fraud. Okay, this is not fraud, but the model can predict. Sometimes predict correctly, sometimes it's predict incorrectly. Okay, and the summary of the result will show you like this. Okay, predict false, and the actual value is false is 63, and the true value is it's true, and the prediction is false. This is error from prediction. Okay, and the overall accuracy of this, it doesn't show accuracy, but it shows precision and recall, which is compute from false positive and false negative of the prediction. Okay, this is an easy tools that you can use. If you have data, then you can just use this box to pull data in and use different machine learning algorithms such as a decision tree, neural network Bayesian algorithms to process our data and predict data, predict the result based on the data, and it's very easy to use. Okay, but it has some limitation. I think you can process up to 100,000 rows of data. More than that, you have to pay. You have to buy license. Okay. Okay. It's the end of my presentation, and I want to give you some key to takeaways from this talk. Data science is multidisciplinary knowledge that focus on discovery, information, or the value from data. Okay, so if you have data science will try to discovery knowledge or the value. Okay. Data science is a process. It can be viewed as a process. Start from collecting data, cleansing data, create model, or even create applications. Okay. There are several approach and algorithms that I showed you earlier, different machine learning algorithms, depend on the goals and the type of the data that you have. Okay. The data science can be become more easily implement. Like I show you the tools that I showed you previously, RapidMiner, it's just drag and drop. And in the future, it's become even easier. So the people with less technical skill can use in the future. The people in the computer science community try to make this tool easy for end user. Another important thing that I did not mention is the ethical issue in data science. There been a controversial topic on this topic in data science AI communities. If it misuse or use it without understand, it will be bad. For example, there's some news that the bank tried to approve loan or not approved loan based on the data of the customer. And that model can be incorrectly trained, or the data that used to train the model may be bad, and that create some lose benefits of the person who actually qualify for the loan but not getting the loan because the bank decide based on the data that they have. So this still some issue that being discussed in the data science community. Okay. Now I will open for question, or if you want to discuss any topic that I talked earlier, I'm welcome. Okay. So any question?
Thank you very much, Dr. V, for your very experience, and knowledge on the data science that you're sharing with us today. I have a question. Do we need to have a minimum threshold for the data size?
Threshold on the number of data?
Yeah, the number of data.
Okay, depends on the application. The data science use the similar technique as the statistics, where we place the confidence on the number of data. If we have more data, then we more confident on the results. But if the data only maybe 100 or 200, then we're not very confident on the result. Similarly, in the statistic, it has some interval, right? Confident interval. Whether we confident or not confident on the result. Again, data science is the same thing.
Thank you very much. Does the audience have any question for Ajahn V? You can asking his the question in Thai language also, because he can speak Thai. So
ภาษา
yeah.
ไทยได้ครับ เห็นไหมครับ
No question. Ajahn V, I just wondering what kind of research are you working on right now? In terms of data science, and is related to behavioral science or not, and how can we work together or something like that?
Okay, I currently I mainly focus on text analysis and general data science, meaning that any data with number. Right now, I try to extract data from a research paper. Right now, I try to group based on the paper title that published in Scopus. I try to group them into maybe people from science and people from human, maybe work on the very similar things, but they don't know each other. Then if we look at the subject, then we can relate them together, and that can create a research community within the Srinakharinwirot University research community. But any other subject, like I said, we have 12 faculty members in the computer science department. I think we cover all the subject. If you're interested in any subject, I can arrange a meeting with our faculty members. And again, not only that computer science work on data science research, there's so engineering, they also work on in this field as well.
Thank you ค่ะอาจารย์ V. I think our student have a question. น้องเชนป่ะน้องเชนสามารถถามคำถามอาจารย์ V ได้เลยค่ะ
ครับผมก็พอดีผมก็สนใจเรื่องนี้อยู่นะครับแต่ว่าเห็นว่าปัจจุบันเนี่ยเราก็ไม่สามารถที่จะดึงข้อมูลมาจาก third party อย่างพวก Facebook Twitter อะไรอย่างเงี้ยได้เงี้ยครับอันเนี้ยถ้าเราต้องการที่จะวิเคราะห์พฤติกรรมของ ของคนที่อยู่ในโลกโซเชียลเนี่ยเราจะมีวิธีในการที่จะเก็บข้อมูลจาก third party หรือจะสร้างเครื่องมือในการเก็บข้อมูลใหม่ได้ยังไงบ้างครับ
โอเคอย่างของ Twitter เนี่ยเขาจะมี API ให้เราไปดึงได้นะครับเพราะ Twitter เนี่ยมันก็เป็น Public เนาะเราสามารถไปดึงได้เลยแล้วก็แค่บอกว่าใส่ subject อะไรเช่นเราบอกว่าเราสนใจเรื่อง traffic เรื่องจราจรอย่างเงี้ยเราก็ใส่จราจรไปอย่างอย่างตอนนี้ผมมีนิสิตที่ทำงานกับผมเรื่องพยายามจะวิเคราะห์ depressionว่า people จากข้อมูลที่เขาทวีตเนี่ยมีคนไหนบ้างที่เป็นรู้สึก depressed อะไรอย่างเงี้ยซึมเศร้าทีเนี้ยเราไม่มี data เราไม่มี data ไม่มีหมอบอกว่าอันนี้คือ depressed อันนี้ไม่ depressed สิ่งที่เขาทำก็เลยเขา make assumption ว่าถ้าเกิดเขาเสิร์ชคำว่า happy บน Twitter แล้วเขาก็ไปดึงข้อมูลมาเป็นน่าจะเป็นหมื่นเนี่ยเป็นหมื่นข้อความหมื่นทวีตเขาบอกว่าถ้าเกิดเขาใช้คีย์คำว่า happy เนี่ยอันนี้คือคนปกติแต่ถ้าเกิดเขาใช้คำว่าเศร้าจังใช้คำว่าเศร้าใช้คำว่าเหงาใช้คำว่าเสียใจอะไรเงี้ยอันนี้คือ depressed เขาก็ make assumption อ๋อนี่คือ depressed นะเขาก็ไปดึง Twitter ที่มีคำพวกนี้อยู่ที่มีแท็กพวกนี้อยู่เสร็จแล้วเขาก็มาสร้างเป็น two data set อันหนึ่งเป็น happy อันหนึ่งไม่ happy แล้วเขาก็มาสร้างmachine learning model แล้วก็ทำนายอนาคตว่าถ้าเกิดคนทวีตมาใหม่เนี่ยคนไหนจะเป็นรู้สึก depressed ไม่ depressed อะไรประมาณนี้อันนี้ Twitter ดึงได้เลยส่วน Facebook เนี่ยมันจะมีข้อมูลที่เป็น public กับไม่ public ข้อมูลที่ไม่ที่เป็น public เนี่ยก็ดึงได้เขาก็มี API ให้แต่ถ้าไม่เป็น public ก็คือที่มันเป็นโพสต์ส่วนตัวนี่ก็ดึงไม่ได้อยู่แล้วนะครับเพราะว่าเป็นข้อความเขาแต่ถ้าเราอยากจะไปดึงข้อมูลของคนที่เราเป็นเพื่อนอยู่อันนี้ก็เป็นไปได้เราอาจจะใช้วิธีการเขียนโปรแกรมเพื่อไปอ่านหน้าจอก็คือเปิดหน้าจอปุ๊บแล้วก็อ่านข้อความเปิดหน้าจอแล้วก็อ่านข้อความเปิดหน้าจออ่านข้อความอะไรอย่างเงี้ยทำได้
ขอบคุณครับ
สวัสดีครับอาจารย์
ครับ
อาจารย์สรัญจากสถาบันวิจัยนะครับอาจารย์คือเท่าที่ฟังเนี่ยมีคำถามหมายถึงว่ามีข้อสังเกตหรือสงสัยประเด็นเรื่องแบบความพร้อมของอุปกรณ์หรือฮาร์ดแวร์ซอฟต์แวร์ที่เราใช้อย่างเงี้ยครับดูเหมือนว่าน่าจะต้องใช้แบบสเปคสูงมากๆเลยอ่ะคือแบบอยากรู้ว่าโน้ตบุ๊กหรือคอมเดสก์ท็อปเราปกติดูไม่น่าจะใช้ได้ในแง่ของการเอามาทำพวก data mining หรืออะไรประมาณนี้ไหมครับมันต้องมีสเปคขนาดไหนอะครับอาจารย์
โอเคมันอยู่ที่1ชนิดของ data set แล้วก็ชนิดของอัลกอริทึมที่เราอยู่ที่เราใช้ถ้าสมมุติว่าเราเลือก simple algorithm นะครับอย่างเช่นพวก decision tree เมื่อกี้ที่โชว์ให้ดูนะครับdecision tree เนี่ยไม่ต้องใช้คอมอะไรเยอะเลยเพราะว่ามันเป็น simple algorithms ถึงแม้ว่าจะมีข้อมูลเป็นแสนแถวแสนโลเงี้ยdecision tree สามารถคำนวณได้บนเครื่องคอมพิวเตอร์ธรรมดาได้เลยทีนี้มันก็อยู่ที่ว่าก็อยู่แค่ว่ามีแรมพอหรือเปล่าเพราะเวลาข้อมูลเยอะๆมันต้องเก็บในแรมเนาะทีนี้ไอตัว CPU เนี่ยไม่มีปัญหามัน process ได้อยู่แล้วแต่ว่าการที่โหลดข้อมูลเข้ามาเยอะๆเนี่ยอาจจะต้องมีแรมเยอะหน่อยอาจจะสัก8กิกหรือว่า16กิกอะไรอย่างเงี้ยถึงจะ process ข้อมูลได้แต่ถ้าเกิดสมมุติว่าอาจารย์ไปใช้อัลกอริทึมนี่มันซับซ้อนแต่แน่นอนความซับซ้อนมันก็จะให้ความถูกต้องเยอะกว่านะครับมันก็จะต้องใช้CPU ที่ใหญ่ขึ้นหน่อยที่ดีขึ้นหน่อยหรืออาจจะต้องใช้ GPU ที่ใช้พวก Deep Learning อะไรอย่างเงี้ยนะครับซึ่งมันก็มี2 ช้อยที่1ก็คือซื้อเครื่องมาเองนะครับซื้อเซิร์ฟเวอร์มาเองมาตั้งแล้วก็คำนวณหรือเราจะไปเช่าคลาวด์ข้างนอกนะครับเช่าคลาวด์ข้างนอกก็ได้ก็คือถ้าเกิดเราจะใช้สั้นๆเนี่ยก็ไปเช่าคลาวด์ก็จะคุ้มกว่านะครับแต่ว่าถ้าเกิดเราจะทำแบบ continue research อะไรอย่างเงี้ยก็ซื้อเครื่องมาเลยก็ดีอย่างที่ภาคก็ซื้อเครื่องมาเพราะว่าทุกเทอมเนี่ยมันก็จะมีนิสิตที่จะต้องเข้าไปทำโปรเจกต์เพราะฉะนั้นเราก็ตัดสินใจว่างั้นเราก็ซื้อเครื่องมา นะครับแต่ก็เครื่องก็ไม่ได้ใหญ่มากนะครับเขาก็แชร์กันถ้าเกิดมีคนแย่งกันใช้เยอะๆเขาใช้ไม่ไหวเขาก็ไปซื้อข้างนอกเอาอะไรประมาณนี้ครับ
ครับอาจารย์ขอบคุณครับ
ครับ